Hello students, in this video we are going to see the structures of interhalogen compounds. Now you know what interhalogen compounds are. So let us take the examples of XX-, XX-3, XX-5 and XX-7 type of compounds and know what are the structures and type of hybridization. So let us start with the first type, that is XX1. So this is the first one, that is XX-. Example here can be ClF. I'm taking one example. You can have BRF, you can have IF, this type of compounds. Now here the central atom is chlorine. So chlorine atomic number is 17. No need to write the complete electronic configuration. So how I will write this as 2, 8 and 7. So the valence electrons are in the third principal quantum number. So taking into that, let us draw chlorine. Here chlorine is the central atom. So let us draw the X in its ground state. Now, as I said, we are moving on to the third principal quantum number, but if you take this as bromine or iodine, it will go to 4 and 5. Therefore, I will write the electronic configuration in terms of N. So here it will be your NS. This is your NP, and we always keep the d orbital vacant so that in case required, you can carry out the excitation. So let us keep the d orbital vacant. So this is your Nd. Now let us fill the electrons. You know that there are 7 electrons. So let us fill the electrons 1, 2, 3, 4, 5, 6 and 7. So you have to follow Hund's rule while filling the electrons. Now, if you see here, the connecting atom here is only 1 and therefore I require only 1 unpaired electron so that this fluorine can overlap here. So there is no need of any excited state. So excluding that step, let us come to X in its hybridized state. Students, as the number of connecting atoms is equal to the number of unpaired electrons, there is no need of carrying out any excited state. So let us write the hybridized state here. You know that when the hybridization takes place, there is mixing of the atomic orbitals. So let us mix the atomic orbitals. So what all orbitals will get mixed is your NS and NP. D will remain as it is. So let us mix them and draw it. So what you have here is this. So 2 electrons here, 2 electrons here, 2 electrons and 1 electron here. So in this hybridized state, you have 1s and 3p orbitals involved. So this will undergo sp3 hybridization. Now if you see this, there are 3 lone pairs, the first, second and third. So it will be sp3 hybridization with 3 lone pairs. Now fluorine or the connecting atom, that is X dash, that will overlap here and the bond will get formed. So what will be the structure here, student? You know that for regular sp3 hybridization, the geometry will be tetrahedral. So what can be the structure? Structure can be something like this, the tetrahedral structure. Means your X will be somewhere here and your X dash will be here, and the 3 lone pairs I can place them in this way. So what is the expected structure here? This is your lone pair. This is the second lone pair what you have, and this is the third lone pair here. So only one bond which is formed, that is X to X dash. So you can see this. So this is X to X dash. So the geometry is linear. Right, students? So this is the first interhalogen compound we have seen. The hybridization here is sp3 hybridization. Regular geometry expected is tetrahedral, but as there are 3 lone pairs present, therefore the geometry gets distorted tetrahedral, or to be more accurate, geometry becomes linear. Let us move on to the second interhalogen compound, and that is X-3. Now, on the same basis, I will write X in the ground state. So let us draw this. Simultaneously, you can draw this, student. It will be a practice for you all. So if you see this, I'll again keep the d orbitals vacant here. So this is your NS, NP and ND. Let us fill the electrons. 1, 2. You have to fill the electrons always following Hund's rule. Here ND is vacant. Now if you see this, there are 3 connecting atoms and therefore you require 3 unpaired electrons here in the X atom. And so here I need to carry out the excited state. So how I will excite the electron? This electron from here will get excited to this vacant orbital. So you have to write the excited state. So X in excited state will become, this will remain as it is. This will become 1, 2. This will 1, 1 and 1 electron will move on to this. So you have NP and ND in this way. Right? Now let us go for X in the hybridized state. Now you just check whether the number of unpaired electrons now they are matching with the number of atoms. So up to this excitation is sufficient enough to carry out the hybridization. So let us move on to the hybridization now. If you see the hybridization, which orbitals will be involved here? This one, the first one, all the 3 P's will be involved and this one D will also be involved. Let us fill the electrons now. So you have this in this way. Now how many orbitals are involved? 1 of S, 3 of P and 1 of D. So this will undergo S, P3, D type of hybridization. So this X and X3 will undergo sp3d hybridization. Now what should be the geometry? For that, students, what you have to do is, this is 1 plus 3 is 4 plus 1 is 5. Subtract 2 from it, so you get 3. So what is the proper geometry of 3? Is a triangle. So I will try to draw a triangle and then what I have subtracted, I'll put 1 up and 1 down. So expected geometry is trigonal bipyramidal. Right? But if I see the hybridized state here, there are 2 lone pairs. This is the first one and this is the second one. So I have to locate the lone pairs, and in this type of geometry, the lone pairs, they are always placed at the equatorial position. So I will place the lone pairs here on the equatorial position. So the geometry what I get now is a T-shaped geometry. You can see this, a T is formed. But as the 2 lone pairs are here, they will push the bond pairs down. You know that lone pair interactions, they are more than the lone pair or bond pair. And therefore, this shape will turn to something like this. What you have, call it as a bent T-shaped geometry. So actually the structure for this appears something like this. If I want to take the example of ClF3, then in ClF3, how the molecule looks like. So this is your Cl and the 3 fluorine atoms, they will be in this way. The first one, second one and the third one. So this looks like a bent T if you can make out. So this is your fluorine, fluorine and fluorine. Now the bond lengths here is nearly 1.698 angstrom unit. So this is also same 1.698 angstrom unit, and same here 1.698 angstrom unit. Now the bond angle here, it should be actually 90, but it decreases, so it becomes 87 degree and 29 minute. So this is the structure of ClF. And the type of hybridization here is actually trigonal bipyramidal, but because of the lone pairs, it becomes bent T, or you simply call this as T-shaped. Let us move on to the next interhalogen compound. So the third type what we have is X-5. So let us start writing ground state electronic configuration. So that is you will have NS, NP and ND. So 1, 2, 1, 2, 3 and the pairing in this way. So this is the halogen in its ground state. Now if you see this, how many unpaired electrons I want? I want 5 unpaired electrons here, but here there is only 1 unpaired electron. So I need to carry out the excited state. So I will shift this electron to this. So let us see what happens after the first excitation. So write down X in the excited state. Which excited state, student? This is the first excited state. So in the first excited state, what you will get, this will remain as it is. It is not necessary to draw all the 5d orbitals, but it's better if you have time, you can draw it. So this is what you have. Now how many unpaired electrons you have found? Is 3 unpaired electrons. I want 2 more. So let us go for the second excitation. So X in the second excited state. So I need to excite 1 more electron, and so this electron I will excite to this. Never ever make a mistake of pairing the electrons here, because we want the unpaired electrons. So what you will have here, this will remain as it is, that is NS. Now this p orbital will have 1 unpaired electron each, and the d orbital will have 1, 1 in this way. Right? Now if I see the interhalogen compound, here there are 5 connecting atoms. Here also I have 5 unpaired electrons. So now the atom is ready for hybridization. So let us write down X in the hybridized state. Collect all this. Why we are writing that on 1 energy level? Because their energy gets mixed up, and therefore they all have the same energy. We call them as degenerates. So this is what you get: 1, 2, 1, 1, 1 and 1, 1. So what type of hybridization this will undergo is sp3d2 hybridization. Now let us assign the geometry for this. So to assign the geometry, this is 1 plus 3 is 4, 4 plus 2 is 6. Subtract 2 from it, so you get a square. So the geometry will be something like this. Now what you have subtracted, you put 1 up and 1 down. So this is the expected octahedral structure. But if you see the electronic configuration in the hybridized state, there is 1 lone pair. Now in this octahedral type, you have to place the lone pairs on the axial positions. So those are the axial positions. So I will place the electron pair here, or you can place it down if you want. Now this is the structure for this interhalogen compound. So the expected geometry is octahedral, but because of that lone pair, the geometry gets distorted, and the proper name for this is square pyramidal. So this is the geometry for X-5 type of interhalogen compounds. Let us move on to the next one, that is X-7. On the same basis, let us start X in the ground state. Now student, by this time you know that you have to create the number of electrons equal to the connecting atoms, right? So this is what the ground state electronic configuration I am writing. Now how many unpaired electrons I want? is 7 unpaired electrons. Taking help of the previous electronic configuration, here I have created 5 unpaired electrons. So by this time you might have understood that I need the third excitation also. So taking into consideration, I will write that X in the third excited state. So after this step, you have to show that this electron also gets excited to this. So what I will have here in the third excited state is this electron here, 1, 2, 3, and now there will be 3 electrons in the d orbital. So it will be like this. Now write down X in the hybridized state. So what will be the hybridized state here, students? The hybridized state will be, this will be in this way. So you will have 1, 2, 3, 1 and 3. So 1 and 3 and 3. So 1, 2, 3. So what type of hybridization will be this? Is sp3d3 type of hybridization. Now this is what XX-7 type of compounds they look like or in hybridized state. You can have this as an, now if I want to take this example for, say for example iodine, then very easy to recall that. Say for example chlorine atomic number is 17, its valence electron comes in third principal quantum number. Then for bromine the valence electron will come to 4. So if you want to write the same for bromine, this will become 4s, 4p like this. If you want to write for iodine, this will become 5s, 5p and 5d. So like that you have to write. Let us come to the hybridization now. This is 3 plus 3, 6 plus 1 is 7. Subtract 2 from it. So what you get is a pentagon. So let us draw a pentagon first. So this is a pentagon, how it looks like. Now, what I have subtracted, 1 up and 1 down. So the structure here is pentagonal bipyramidal. When one of the bond is up and one is below, you call this geometry as bipyramidal. So this is the structure. If I want for IF7, then how I will show this? This is your iodine and those are your fluorine atoms. So this is the structure for IF7. So this is all about the interhalogen compounds. Thank you, students.